Hello, and welcome to this video on parallel computing. I'm here to provide you with valuable insights. The voice you're hearing is AI-generated, and this video is supported by the Norwegian Research Infrastructure Service. This involves collaboration between the universities of Bergen, Oslo, Tromsø, and NTNU, and working with Sigma 2 to manage the national e-infrastructure. In this video, we'll demonstrate how to type Linux commands faster using autocomplete. We'll also discuss the benefits of scripting versus typing. We'll use the Saga Linux cluster, so let's log in. Upon logging in, we'll encounter a welcome message containing useful documentation and support details. Additionally, we'll receive updates from the ops log along with any important notes and warnings. We can use the pwd command in Linux to see our current location in the file system. This command prints the full path, showing that we are in the home folder on the cluster. On the Saga Linux cluster, every user can access a special work folder on the file system. Let's navigate to my folder in this location using the cd command. We can confirm the path to this folder by using the pwd command. This Linux command will display the full path to this folder. Observe the change in my command prompt. Your command prompt will always indicate your current location on the Linux cluster. Note that tilde is a symbol for the home folder. We can check the contents of this folder using the ll command. The folder is currently empty. It's important to note that there's an automatic cleanup feature in place for this folder, which will remove any files after either 21 or 42 days. When we logged into Saga, you might have noticed a note about this folder. Why do we need it? This folder is useful for submitting jobs to the compute nodes with a job script. While you can submit job scripts from your home folder, like we did in our video on applying OpenACC on the A100 nodes, there are some limitations. If your job generates a lot of data, your home folder might run out of storage, causing your job to stop. This problem can be avoided by submitting jobs from the work folder. Additionally, if you need to reorganize your home folder, such as changing file and folder names, moving files around, or deleting them, you might encounter issues with unfinished jobs submitted from the home folder. To prevent these problems, submit your jobs from the work folder instead. First, we'll create a directory in the work folder using the mkdir command, which stands for make directory. We'll name this directory OpenMP on A100. In our next video, we'll use this directory to submit job scripts and explore GPU offloading with OpenMP. We can use the ll command to list the contents of our work folder and verify that the directory has been created. Note that the directory name appears in blue, which indicates that it is a directory and not a file. We can navigate to the new directory using the cd command. Once inside, we can use the ll command to view its contents. As expected, the directory is empty because we just created it. I know there's a Fortran program called mxm openmp gpu in the mxm directory within my home folder. To confirm its existence, I'll use the ll command. Since I'm currently in the work folder, I need to specify the full path to the Fortran program. The ll command will display details about the Fortran program, including its last modification date, which was May 16th. We'll copy the Fortran program to the newly created OpenMP on A100 directory within the work folder. To do this, I'll use the cp command, short for copy, and specify the complete path to the Fortran program. I'm using a dot to indicate that the Fortran program should be copied to my current location, which is the OpenMP on a 100 directory inside the work folder. We can use the ll command to check if the program has been copied to the new directory. The output confirms that the copy was successful. I know my testing GPU script is in the MXM directory within my home folder. I can confirm its presence by using the ll command on this script. The ll command shows that the script is in this directory and was last modified on May 13th. Note that the script appears in green, indicating it is an executable file. Let's copy this script in the same manner we copied the Fortran program. We can confirm the script has been copied by using the ll command. The ll command reveals that there are now two files in the directory, the Fortran program and the testing GPU script. It might seem like I did a lot of typing to provide the complete paths, but I used a feature called autocomplete to speed up the process. How does autocomplete work? Let's demonstrate by copying a job script from the MXM directory in my home folder. We'll use the same copying method as before, but now with autocomplete. I start by typing the cp command followed by /c at the command prompt. I know the full path begins with this, so I'll type that and let autocomplete complete the rest. After typing the initial letters, I press the tab key to autocomplete the path. However, no completion occurs even with multiple tab presses. This issue arises because there are several folders that begin with C. Let's include an additional letter in the word cluster to narrow down the options. After that, press the tab key again to check if the path autocompletes. Autocomplete filled in the name cluster but stopped there, as there are several directories inside the cluster folder. We'll start by typing H, the first letter of home. Next, press the tab key to see if it completes the path. Autocomplete successfully filled in home, but it couldn't complete my username due to the presence of many users in the home directory. Now I will input the initial letter of my username. Pressing the tab key doesn't complete the username since several users have usernames beginning with J. There are also many users with usernames starting with JI, so I need to type the first 3 letters of my username. I can then press the tab key again. Autocomplete completed the rest of my username but couldn't go further in the path because there are many directories in my home folder. I'll now type the first letter of my MXM directory. I can press the tab key but nothing happens because there are multiple directories starting with M in my home folder. Next, I can enter the following letter in the name of my MXM directory. I'll press the tab key to see if it completes the input. Autocomplete finished successfully, and I now have the complete path to my job script. I can start by entering J, the initial letter of my job script's name. Will anything occur if we press the tab key? The first part of the job script's name was successfully completed. I know that the next character in the file name is an underscore. I will now press the tab key. More of the job script's name has been completed. I can type in the next letter M. Can the tab key now finalize the file name of the job script? The job script's name is now complete. We can now include the dot in the copy command. Pressing Enter will now copy the job script to my work folder. We can use the ll command to confirm that the job script has been copied. The ll command displays details about the files in my new directory within the work folder, confirming that the job script has been successfully copied. While autocomplete can speed up command entry in Linux for greater efficiency, I recommend using more scripting and less manual typing. I have created 5 Python scripts so far, and in our next video, we'll use the testing GPU script. These scripts, though time-consuming to create, can be used multiple times, making your work more efficient and providing valuable documentation of your processes. This is particularly important for performance testing, where consistency is crucial for comparing different parallel computing approaches. We've dedicated more time to discussing Python scripts than the Fortran matrix multiplication program in our videos. As a result, you've probably learned more about Python than Fortran. But remember, Python's utility goes beyond just performance testing. It's also great for automating a variety of routine tasks. Initially, typing commands directly might seem faster, but scripting proves to be a time saver as you progress. Regularly typing out the same commands can be time-consuming and inefficient without the use of scripts. As mentioned, in our next video, we will use the testing GPU script to demonstrate GPU offloading with OpenMP. OpenMP, Open Multiprocessing, is used for parallel programming in C, C++, and Fortran. With the introduction of the target directive, OpenMP enables you to offload computations to a GPU, enhancing the performance of your applications by taking advantage of the GPU's parallel architecture. I am looking forward to the next video, wishing you all happy computing in the meantime.